For help with the deer, case study number 4, deer, predation, or starvation, you came to the right spot. I'm getting ready to graph here. So remember, wolves are in red, deer's in blue. So look, if we number this, how you number the side. Wolves are in red, so you start at 10 at the bottom, go up by 2, skip a line, 10, 12, 14, 16, 18, 20. That allows you to use the whole graph. If you didn't skip a line, your graph would like only go to here. All right, so for the deer in blue, start at 1900 on the bottom, and then go up by 100 and skip a line, 2000, 2100, 2200, 2300. So yours should be numbered like this. Years on the bottom, 71 to 1980. Remember, we're graphing this data right here. So I'm going to move this data over here so I can see it. And bring this back. All right, so in 1971, I see we're going to do wolves first. So in 1971, there were 10 wolves. So I'll put a line or dot right there because there's 10. In 1972, there were 12. 72, I go up to 12. You really shouldn't have to watch me do this because you should know how to graph. 73, there were 16. Boom. 74, there were 22. So wolf population is going up. Boom. In 75, there were 28. 75 would be here. 28. And that was their peak. Because in 1976, they went down to 24. Make sure. So dark one. 1976, they go down to 24. So right there. 1977, they go down to 21. 77, they go down to 21. So they'll be halfway between 22 and 20 right there. 1978, 18. So 78, they went down to here. 79, 19. 79, so they went back up just a little bit right there. And in 80, they stayed the same right there. Boink. All right, now just grab your little thing, little lines, make sure it's red. Let's go ahead and connect the dots. A lot easier to do it with this line thing than it is to draw them. If you draw them, they're not straight. And it's hard to draw them. All right, connect all the dots. Boom. So this is my wolves graph. I'm only going to be halfway done. Because I also got to do deer. And voila. All right, switching the drawing tool, going to blue. Now I'm doing the deer population. So this is a different set of numbers. 1971, there were 2,000 deer. So here's 2,000, blue. Boink. 1972, there were 2,300. So there's 2,300 right there. 1973, there were 2,500. So here's 2,500 right there. 1974, they start to go down because the wolves are starting to eat more deer. So 74, there were 2,360. So 73, there was that. 74, 2,360. So go up. 21, 22, here's 23. So it's going to be a little bit over that. Boom. Because this will be 2,350. It's 2,360. 1975, 2,244. So here's 2,200. Here's 50. So it's just a little below, right about there. 76, 2,094. All right. So here's 2,000. Here's 2,100. So it's just a tiny bit under that. 77, 1,968. So that's just a tiny bit under 2,000, right? 1,968. So about right there. 78, 1,916. So now there's barely over 1,900. So it's way down here. Boink. 79, they go up a little bit. 1,952. So here's 1950. Tiny bit over that. In 1980, there was 1,972. So it'll be right about there. So they started going up again. And get my little shapes, switch it to blue, and connect the dots. Boom. Boom. I screwed up. Knew it. Eraser. Wink. Boom. 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 All right. And voila, just like this, I'm going to have a wolf graph and a deer graph. And you can see the relationship. When deer goes up, that causes the wolf population to go up because there's a lot of wolves. But now there's a lot of wolves. So that causes the deer population to go down because the wolves are eating them. Well, now there's less deer, so now the wolf population also goes down. Well, once it gets down, now the deer population is going to start to go back up, and that'll cause the wolf population to go up. So the deer and the wolves, predator prey, they affect each other. When the prey goes up, the predator goes up. But a lot of predators, that'll cause the prey to go down, which then causes the number of predators to go down. All right, so let's answer some of these easy questions. Would have been better off for the ecosystem if more wolves had been introduced in 1971. Anything is valid. I'm going to say yes, because fewer deer would have starved. As you can see, if you look on the data table, in 1973, 500 deer died of starvation, and there were only 2,500. So 20% of the deer died of starvation. That's not good. You don't want them to die of starvation. But once the wolves took over, no deer died of starvation because they didn't run out of food, because the deer population was kept in check by the wolves. Give some probable reasons why the wolf population declined after 1975. I would say because the deer population went down. Deer population went down. And I like this red. I'm going to switch it. Yeah, it's good enough. Red. Red. All right, so the deer population went down, so the wolves were like, hey, what happened to all the deer? There's not as many deer to eat. So that's why the wolf population went down, because they didn't have as much food to eat. In which year was deer starvation the greatest? That was 1973. According to my data table, that's when 500 deer died of starvation. From your data and knowledge of ecology, explain why so many deer died that year. They starved because they ran out of food. So they ran out of food because there's too many deer. There's only so much grass for the deer to eat. And when there wasn't wolves, to cut the number of deer down, they ran out of food. They starved to death. Predict what might have happened to the deer population and starvation if hunters had been allowed to kill half of the wolf population in 1974. Okay. Well, if there's fewer wolves, there would be more deer and more of them would starve. So fewer wolves means more deer. More deer means there's not going to be enough food for all of them. So someone would have to start starving to death. 6, what other factors besides predation can control or limit the population of deer? These are limiting factors. So it could be things like space, not like outer space, but how much space is there? Is there enough room? Amount of food. There's only so much food. That's going to limit the size of a population. Water. How much water is there? When you run out of water, the deer can't live. So those are limiting factors that would limit the population of deer. A couple of them: space, amount of food, water, also diseases. 7, how does the size of the deer population influence the number of wolves on the island? Oh, man. The more deer there are, the more wolves there will be. So if there's a lot of deer, it's going to be a lot of wolves. If the deer population goes down, that's going to cause the wolf population to go down. So they're kind of connected together. If no hunting is allowed, what natural mechanisms will control the wolf population? The amount of food they got. It's going to be the amount of deer available. If there's tons of deer, you can have tons of wolves. But if there's not that many deer, you can't have that many wolves because they're going to run out of food. If the deer population is to remain steady at 2,000, and the number of deer offspring, babies, is 1,000 in 1981, how many deer would each wolf have to eat in a year? So we want to keep it at 2,000. So if there's 1,000 baby deer, that's going to turn it into 3,000. So the wolves are going to have to eat 1,000 deer. And we have 25 wolves. Well, how many deer does each wolf have to eat? Well, that's just 1,000 divided by 25. And that's going to be 40. So each one of those 25 wolves has to eat 40 deer in order for the population to stay at 2,000. All right, graph number 2, drawing tool. This time I only need any color will do. I'll stick with blue. All right, so this is an age diagram. So 0 to 1, I need to get my other data. All right, got it now. So you're looking at the data table. It's on the bottom, not the top data table, but the bottom, age and number of deer. 0 to 1, so baby deer, there's 860. Here's 800, here's 850, there's 860 right about there. 1 to 2-year-old, there's only 345. So you can see a lot of those babies, there's 350, 345, just barely under it. So a lot of those babies died that first year. So the wolves are wiping out the young ones because they can't run very fast. They're easy to catch. 2 to 3 year old, there's 262. 200, here's 250, there's about 262. 3 to 4, 168. There's 150, 168, be right about there. 4 to 5, there's 105. Here's 100, barely over it. 5 to 6, there's 88. There's 50, so it'll be a little over right about there. 6 to 7, there's 68. Here's 50, 68 will be all right about there. 7 to 8, there's 56. So there's 50, just barely over the 50. That's close enough. 8 to 9, 42, so barely under the 50. 9 to 10, there's only 6. So these probably also got picked off by the wolves because they're so old they can't run, or they died of old age. All right, bring my little shape thing, and let's just connecting the dots. Wink. Wink. There's a bell to go to the 6th period. So I have a class coming in, but I think I can fish it before they get here. Boink, boink, boink. So you can see the vast majority of the deer are young deer, but most of those die. So once you've survived that first year, then you tend to survive longer because once you got older, you're smart enough and fast enough to get away from the wolves. All right, let's see here. Which stage of life has the highest mortality rate or death rate? That's where it drops the biggest. And that's going to be between, we'll go between 0 and 1 year old. So just any environmental factors that might make this death rate so high. I'd say the wolves were able to catch the younger deer. And if you saw it on the start, on this one, you can go. All right, so there you have it. There's the deer predation, starvation. Do the best you can and make sure you submit it. So, here's all the answers, so everybody should do it. All right, and I'll see you next time.